This video covers electric voltage difference. So imagine that we have a positive charge in an electric field. An agent must exert some work on the positive charge to move it against the electric field. We know that the work will be positive since positive charges do not naturally want to travel in this direction. The definition of electric voltage difference between 2 points is the work an agent must do to move the charge divided by the charge of the charge. So it is important to stress that the voltage difference is the difference between the voltage level at the final point and the voltage level at the initial point. We will discuss particular voltage levels later. The units for electric voltage difference is a joule per coulomb, which is also known as a volt. Something else that is also important to note is that voltage difference between 2 points does not depend on the charge that is moved. So potential voltage difference or electric voltage difference is always going to be the same. If a larger charge is moved between the same 2 points, the work will then also be larger, so everything balances out. Let's do an example. A positive 4 microcoulomb charge is moved between 2 points, requiring some agent to do 6 times 10 to the negative 3 joules of work. Calculate the electric voltage difference between the 2 points. So we know that the equation for voltage difference is the work to move the charge divided by the charge that's moved. We can fill in the values that were given, and we see that the voltage difference was 1,500 volts. Next, we want to calculate the work to move a negative 10 microcoulomb charge between the same 2 points. So we know that the voltage difference and that the charge that was moved, right? And our voltage difference we calculate in part A, and we know that the voltage difference does not change even though different charges are moved. And we see that the work to move this charge is negative 1.5 times 10 to the negative 4th joules. So notice that the work is negative. This means that the force exerted on the object is in the opposite direction of the displacement, which means that the force that is exerted is a resistive force that is pushing against the object to slow it down as it moves in the direction it wants to. We could also be asked to find the electric voltage difference between several points, like here. Take note that point G has an electric voltage of 0 volts. This is also known as ground. So let's find the electric voltage difference if we go from point G to A. So to do this, we are going to take the initial voltage level and subtract from that value the final voltage value. So remember, we always have final minus initial. And we see the voltage levels at points G and A from the image above. And when we do out this math, we see that the voltage difference by going from point G to point A is 3 volts. Alright, we could also be asked to find the voltage difference if we travel from point C to B. So we are going to take the voltage levels at point B and subtract the voltage level at point C, final minus initial. And we find that the voltage level, or the voltage difference, is negative 17 volts.